In this problem, you're asked to first plot a complex number and then write it in its polar and exponential form. The main focus of this video is going to be writing this complex number in its polar form. So first I want to jump over to our e-text really quick so that we can get the definition of the polar form of a complex number. And we see that this complex number, x plus yi, becomes r times the quantity cosine theta plus I sine theta. That r and theta are no coincidence. They are from the polar coordinates of that same point. And we have a nice little diagram here that we can refer to as well. So I'm going to try to recreate some of that for the problem that we're asked to complete here. So I'm going to start with a reference triangle of some type. So let me just draw in a triangle as best I can on top of this grid. I have this right triangle I see here, and I know that the distance from the origin to this point is r. That r is the same value r that we would end up writing inside of one of these answer choices. Not necessarily that one, but it would be here in the front of that expression. Theta is the angle between the polar axis and that side. So we need to just find this value theta, and at that point we'll have the information we need to put into the correct form for polar form. Now there are also formulas within that same section that give you those specific pieces, but if we draw it like this, we can really relate it to things we already know, like the Pythagorean theorem. This is a right triangle. I know both of the leg lengths, so I can use the Pythagorean theorem to find this hypotenuse to be the square root of 65. I can also use some basic right triangle trig to find this angle inside the triangle. I know that the tangent of that angle, I'm calling it x, is opposite over the adjacent, or 7 over 4. I can take the inverse tangent of both sides to find that x equals 1.052. Now, if that's the value of x, and I need the value of theta, because I know how polar coordinates work, then I would have to take pi, which would be this angle, and subtract x to get theta. And round into 3 decimal places, that would mean that theta is 2.090. Then once you have those parts, just make sure you're choosing the correct setup for the polar form. Enter the exact value for r and theta rounded to 3 decimal places.